Consider this arrow to be fixed to the center at the origin. One end of the arrow is fixed to the center of the origin, but it's moving in a counterclockwise direction, starting off sitting flat on the x-axis, on the positive side of the x-axis. So I want you to think of the arrow starting off. I'm going to put that red arrow back that I had there before. I want you to think of the arrow as starting off right here on the x-axis and just kind of touching the edge of the circle 1 unit away from the center. Does that make sense so far? What are, and by the way, my arrow is a little crooked. Let me see if I can fix that arrow. Right, there we go. Okay, so think of my arrow now sitting right there on the x-axis. It's fixed here, but it can move along the edge of the circle. So my first question was, what are the coordinates of where the tip of the arrow is, where the point of the arrow is? I know we had an answer earlier on, but I'd like somebody to tell me what that coordinate is again, please. Yes, Gary? It's 1, 0. So I'm going to put that in right now. And that's corresponding to 0 degrees. Why am I saying 0 degrees? Because I haven't moved yet. I'm going to be rotating this thing in a circle. Remember, a circle has 360 degrees, by the way. So we're going to start off sitting flat on the x-axis, and we're going to be rotating in a counterclockwise direction, meaning this way. So right now I'm at 0, and my coordinates are 1 and 0. Now, let's start moving it away from the positive side of the x-axis. We put another arrow in, which is going to be pointing straight up along the y-axis. So let's do that. I made that one a different color. I'll make that blue. So now the arrow has moved. It's now straight up, pointing straight up. What would be the coordinates this time? Now, yes, Jay? 0, 1. Okay, gonna put that in as well. Oh, sorry. It would now be 0, 1. And by the way, what angle am I now making? If I started from here, now I'm straight up here. Yes, that's my 90 degrees. I'm going to write that down as well. Right beside that is 90 degrees. What just happened? Let's continue our rotation. Yes. The little degree thing. Yes. You don't let me get away with anything. You know, yeah. But that's a good thing. I appreciate that. Let's continue our rotation now. Remember, this arrow does not move at the origin. The tail of the arrow is like a pin stuck to the origin. Okay? So let's continue with another arrow that's pointing in the other direction to the first red arrow. Right? Okay, why is that not working? Let's touch that here. Okay, and let's touch that. Let's go here. Let's make this, what color would you like? Green? Purple? Okay, purple. Okay, all right, we'll do purple. Okay, so let me put that on here. From here, that does not look purple. That does not look purple at all. All right, we're just gonna live with that. It's another blue line. So what? Big deal. Two things. I need the coordinates of the point where it is now. I need to know what angle we're at this point. All right? So let's start off with the coordinates. Yes, Masumi? I believe you're right. I'm going to write that down. Why is it behaving like this? Okay. So -1 and 0. And what angle have I now turned through to get to that point? Yes, Naomi? 180 degrees. Okay. Let's continue our journey around this coordinate plane. I've done 0. 0 is right up against the x-axis. I've done 90. That takes me to the y-axis. I've done 180. I'm going to take my arrow and point it straight down. And remember, my angle is being measured from the positive side of the x-axis, going in a counterclockwise direction. So let me see if I can get this thing to cooperate to help me to put that line in. An arrow with, we'll go green this time. Let's see if that works. So let's put a line that goes, okay, that does look green. So I need the coordinates of that line. I also need the angle that I've turned through. Yes, Akifa. Okay, so you gave me both answers. That's good. So I'm getting two things. I'm getting the coordinates, which I'm hearing are 0 minus 1. And I'm also getting the angle to be 270 degrees. Now, we can complete this rotation and go all the way back to the starting point, which would mean I'd be back where the red line is. So that would be the same as 0, but it could also be another angle apart from 0. If I've done a whole rotation, then that would now be what, Wanya? 360 degrees. So I'm going to say that this 0 and 360 should both be the same 1, 0, because I'm right back where I started from. Okay, I'm going to make another statement now, which should help you to connect this to trigonometry. It turns out, and I want you to make a note of this on your handout, it turns out that when you hit the sine key on your calculator, the sine key is actually giving you your y coordinate for this arrow that's running around the x-axis. The sine is your y coordinate. It turns out that your cosine key is actually your x coordinate. And it turns out that your tangent key, I just use tan short for tangent, that's actually your y coordinate over your x coordinate. That's actually what you get when you hit that key on your calculator, right? In fact, if I wasn't going to stop on the x-axis or the y-axis and I was somewhere in between, that's going to give me some other point, some other x and some other y, which is exactly what the calculator is giving you when you press the sine and cosine key. And the tangent key is giving you a set of coordinates. I know you never thought of it that way, but that's what it is. All right. Yes. The top line says tan, which is short for tangent, and then it's the y coordinate. Why do I have y there? Oh, yeah, it's a y coordinate over the x coordinate. Yeah, okay. So the y coordinate over the, it doesn't look very consistent, does it? Over the x coordinate. So y divided by the x. Okay? All right, you don't need your calculator. I'm going to use mine. I'm about to pull up my virtual calculator on the screen. I don't know if it's going to come up on the recording, though. Yeah, it might not, but doesn't matter. I'm going to take that calculator. I'm going to make sure it's in degrees. Then I'm going to ask you to tell me to predict what I should get with the following. If I ask for the sine of 0, based on what I just told you, right? 0 degrees, remember, is sitting right here at the beginning on the x-axis, right at the start. That's 0 degrees. Right? I've moved it, so it's 0 degrees. If I now ask the calculator for the sine of 0 degrees, what should the calculator tell me? What number should I expect to get? If I'm telling you that sine is my y coordinate, what number should I expect to calculate? Yes, Yash. I should expect 0. Well, let's find out. Let me hit that equal sign. Look at that, 0. Don't use your calculator, folks. Just look at mine. Yes. Sine of 60? Oh, yes, because 360 and 0 are in the same place. In fact, since you brought it up now, even though I wasn't there yet, I'll do it right now. I'll find the sine of 360 degrees. Look at that. That's also 0. So let's keep going. What should be the cosine of the same 0 degrees? Before I hit that equal sign, you tell me. What should my cosine be? If cosine is my x coordinate, yes, Jaheen. It should be what? Let's find out. Let's hit that equal sign and see what happens. Look at that. That's 1. Absolutely. Let's keep going. The tangent. What should I get if I hit the tangent key for 0 degrees? I said the tangent is a y divided by the x. So what should the tangent of 0 degrees be? Yes, Masumi. Should be what? Sorry? Should it be 1? No, I'm gonna disagree with that. Che? Why do you think 0? Yeah, 0 over 1 is 0. Anything that you divide into 0 is still gonna be 0. So the tan of 0, let's just make sure the calculator is agreeing with me, is 0. Let's change this. Let's go to 90 degrees now. What should be the sine of 90 degrees? So remember now, let me close my bracket here. Remember now that 90 degrees takes me up here. I'm now standing straight up on the y-axis. What should that be? Go ahead, please, Abel. You're thinking the sine of 90 is 1. You want to rethink that? No. Okay, good. That's good. Sine of 90 is 1. Because it's the, like we said, sine is my y-coordinate. It should be 1. So what should the, I'm going to keep this going. Now ask about the tan. Not the tan, sorry. Not the tan. I'm going to ask for the, what did I just do? Sine. I'm going to ask for the cosine of 90 degrees. Think about that. What do you think that should be? Masumi. Well, let's find out. The cosine of 90 degrees is 0. Now you can start filling in that chart. You notice that I gave you, the handout that I gave you has some information on it, and you can start filling that out right now. Right? There's some that I'm going through that you should be able to fill in right now. Now let's get to the tangent of 90 degrees. Right? I'm going to put that in. The tangent of 90 degrees. I'm going to hit that equal sign in a second. What's your prediction though? What I just taught you should give you at least some idea of what that calculator should give me. What do you think, Atifa? Think it's 1? Sure about that? Interesting. What's your answer? An error. What do you think? Huh. They're thinking that my calculator is going to protest and say, no, I can't do it. Because you're asking me to do something I'm not allowed to do. It's like illegal or something. Well, let's find out what the calculator thinks. The calculator says, if I find a tan of 0, it's, whoa, math error. Whoa, didn't like that at all. Did not like that. Why is that? What's going on? Yes. You can't divide by 0. As you know, we've been talking about this all along with restrictions. If you try to divide by 0, things blow up. That's an exaggeration, and I'm just using, that's not a math term. Don't repeat that. Right? Things don't work when you try to divide by 0. It's a restriction. So the tan of 90 is actually undefined, how we normally say it. It's undefined. So what I would do for the tan of 90 is I just write the word stylus, where are you? So, okay, let's put in some stuff that we already know. The sine of 0 is 0. The cosine of 0 is 1. And the tangent of 0 we said was also 0. We're at 90. We said that the sine of 90 was 1. The cosine was 0. And we're saying that the tangent is undefined. So I'll just put UND here. It's undefined, right? Calculator gives you an error message, math error. Can't be done. Don't try that with me. I'm not going to do anything with that. I can't do it. Let's go to 180 now. Fill in what you think is going to happen for 180. Put the 180 on your chart right now. Right? You put in what you think the sine, cosine, and tangent are at 180 degrees. Put it in for yourself before I put it on the calculator. What do you expect the sine, cosine, and tangent to be for 180 degrees? That's what I need you to do right now. Let's start with the sine of 180 degrees. What did you put in as the sine of 180 degrees? You put in 0? You put in 0. I like the fact that you're nodding your head every time. Yes, no matter how many times I ask you the question, you're still putting in 0 because it's 0. The sine is my y coordinate, and at 180 degrees, y 0. We said that. Look at the chart. Look at the circle. So the sine of, and I'll hit the button right now, sine of 180 is actually 0. So I can put that in. Let's get to cosine now. Angeli, what did you write as the cosine of 180 degrees? -1. That's interesting. Let's ask the calculator. Cosine of 180 degrees is -1. I can put that in on my chart as well. Is there anybody who isn't clear on why it is -1? Because I can go over it again. I'm okay with that. Yes, Che, what's the question? Calculator actually wouldn't give you that. It would give you this. Actually, for 180, it would. Yes, it would. It would. Come to think of it, it would. Yes. Take that back. And then the final one is the tangent of 180 degrees. Athuzan, what did you write down for 180? 0, he says. That he thinks the tan of 180 is 0. Let's ask the calculator. The tan of 180 degrees is in fact 0. Okay, let me put that in as well. Good call. How about 270? Now, I think I might have 270 on the other page. I don't. I get to the negative stuff. We'll get to 270. We'll put 270 maybe down here. We'll make up our own. Let me ask you about, because this might come upon when you have your homework, which is going to be that quiz again. You might get that angle. And you can see why I'm asking you not asking. I'm saying you can't use a calculator for this, because if I ask for the cosine of 270 and you just put it on the calculator, what have you learned? Right? What is it that you thought through to get that answer? Nothing. You just put it on a calculator. Let the calculator do the work. So let's get to 270. Let's talk 270 now. If I asked you for write it down, write your answer down, first of all. And I'm going to ask one of you for that answer in a minute. So sine, cosine, and tangent of 270. Okay? Then I'll ask the calculator after I ask you. Let me see. Let me ask Shaluja for what she thinks the sine of 270 degrees is. Shaluja, what do you think? -1, she says. Should I write that down or should we question it? What do you think? -1? What does the rest of the class think? Well done. -1. How about the cosine of 270? Yes, Yash. 0. I'm not even going to go to the calculator because she's right. He's right. And finally, what about the tangent of 270 degrees? Let me go in the back there. Hashim. Did you look at your calculator or did you just figure that out? I don't see a calculator there. I see a calculator on your desk though, so I hope you didn't use a calculator. You just figured it out, right? That's what I need you to do. 270 degrees, the tangent of that is undefined. UND. Now, these are part of your special angles, which you may get when you're doing your quiz on the That Quiz website in a few minutes. Once you see an angle that is on the x-axis or on the y-axis, it's a breeze. I don't want you having to go to a calculator because you're not going to have a calculator for this. You're going to have to do this in your head, right? Just think, okay, so if it's sitting on the x-axis or the y-axis, what are the coordinates of the point where it's sitting at? And that's my sine, cosine, or my tangent. Well, folks, life doesn't exist only on the x and y axis. I'm going to move away from the x and the y axis for now. So we've covered all sort of four major points. The starting point, which will be 0, and also 360, by the way. The 90-degree mark, the 180-degree mark, and the 270-degree mark. We now understand what the calculator is telling us when we punch those numbers in, why that answer is what it is. But let's move away from that. Now we're going to move into some other territory. I want you to think of these two triangles. We're going to start off with this triangle here, which is two, doesn't matter what the units are, centimeters, meters, feet, miles, doesn't matter. It's 2 whatever the unit is here, the same 2 over here, and it's 2 over here, but I've split that 2 up into 1 and 1. What kind of triangle is 2 on all sides, or it's the same on all sides? We call that an equilateral triangle. Thank you very much, Sarah. In an equilateral triangle, can you tell me what each of the angles is in an equilateral triangle? Help me out with that, please. Yes, Jay? Because you got to split that 63 ways. Sorry, you got to split that 183 ways. So each of these angles in the corner here is 60 degrees. This is also 60 degrees. But if I drop the line from the vertex here straight down to the middle of this, which splits it half and half, then each of these angles on either side would be how much then in that case? Yes, Masumi? It would be 30 degrees. So this is going to be 30 degrees on either side. Now, let's do a little Pythagoras' theorem. If this side here, let me go on a brand new page and put that in. I'm going to draw me a little triangle on that page, little right triangle. Not drawn to scale, so don't give me a hard time about that. Let me see if I can. Oh. Let me see if I can change it just a little bit. No, I'll just leave it as it is. Just leave it as it is. Let's pretend for now that this is the 2 centimeter side over here, or 2 whatever it is. This is the 1 down here. It's a right angle right here. Let's pretend for a minute. It's not drawn to scale, so just work with me here. Can we figure out the third side using Pythagoras? Think back to before grade 9. I think from elementary school. How do I figure out the length of that side? Help me out here. Yes, the chair. We'll do that. We'll call it x for now. Thank you. So 1 squared plus x squared is equal to 2 squared. Can we all agree on that? That's what Pythagoras' theorem says. These are the 2 shorter sides. That's the hypotenuse. So that squared plus that squared is equal to that squared. And by the way, yes, Jay? Yeah, we're going to do that next. So this represents the triangle that I have here. It's 2 here, 1 here. We're trying to figure out what this side is. I've already given it away by giving you an answer, but let's just see if we can figure it out for ourselves now. So x squared, as Che was kind of saying, is equal to the 2 squared minus the 1 squared. So it looks like it's 4 minus 1, which is, of course, equal to 3. So therefore, x is equal to the square root of 3. As you know, if x squared is equal to something, then x itself is equal to the square root of that thing. And we're going to leave it as the square root of 3. We're not going to figure out the square. We're not going to run to a calculator. Calculator is going to give us some strange decimal that goes on for, it's what we call an irrational number. So we don't really need that kind of detail. We're going to leave it as a radical. We did a lot of work on radicals in the first unit. We're leaving it as a radical in exact form. So I'm going to go ahead now, and I'm going to, well, it's already on the diagram, but now I've explained to you why this side over here is a root of 3. That side right there is a root of 3. Okay, that's the root of 3 right there. This is 1, this is 2, that's the root of 3. Okay, all right. Now, let's see if we could find the sine of 60 degrees using this, what's called special triangle, in exact form. Not going to go to the calculator and say, Mr. Calculator, can you tell what the sine of 60 degrees is? I really need to know. Mr. Kamak is asking, and I don't know what it is. No, we're not doing that. We're going to figure this out right now using that triangle. Sine of 60. Well, here's my 60-degree angle right there. Let me point to it using the cursor. Here's my 60-degree angle right here. And we know SOHCAHTOA. We did this yesterday. SOHCAHTOA. I'll put SOHCAHTOA where now? Oh, you know SOHCAHTOA. I'll put it on the side of the board right here. We all know about adjacent and hypotenuse and all this other stuff. We all know this. Let's see if we can use that to figure out the sine of 60 degrees without a calculator. According to this triangle, sine of 60 will be equal to opposite over hypotenuse. Well, what is opposite here? What is the hypotenuse here? Yes.
Hypotenuse is 2.
Okay.
And opposite is the 3.
The root 3. Here's what Arya just basically told us, that the sine of 60 is root 3 over 2. That's what she just told me. That's in exact form, right? It's some decimal, and if I put this on a calculator, the calculator would give me some decimal, but I'm not interested in decimal. I'm going to leave it as root 3 over 2. I don't need a calculator for that because I have my triangle, which tells me that if I were to take the sine of 60, it's the opposite side, which is a root 3, over the hypotenuse, which is 2, and there's my answer. Now, if I went to the calculator and asked for the sine of 60, and I can do that right now, sine of 60 degrees, it actually does give me root 3 over 2. Am I going to allow you to do that? Heck no. Okay? There's no chance I'm going to let you do that on a calculator for a test because you haven't thought anything through. You've just asked the calculator for the answer. So there you go, root 3 over 2. So we've done the sine of, how about the cosine of 60? Go back to the diagram again. Look at the diagram. The cosine of 60, same 60-degree angle right there where the eraser is. But cosine, remember, is adjacent over hypotenuse. So now that I've spelled that out for you, what would you say is the cosine of, without a calculator, what would you say is the cosine of 60 degrees? Hashim says he knows. Yes, Hashim. 1 over 2. Thank you very much. It's a half. I can go to the calculator for the calculator to confirm that in a second. It's 1 over 2. It actually is for the cosine of 60. Now, do I memorize that? I don't. I draw my triangle every time I have to do that if I need a special angle. You're allowed to keep this handy for when you're doing your online exercise later on. Not a calculator, but this. Yes? Because it's better when you're doing your exercise online, it's going to come up as 1 over 2. And of course, as you know, 0.5 is the same as 1 over 2 anyway. So as a fraction, it's better though. Okay? Fractions rule. That's my motto. Fractions are better than decimals any day. That's just a personal opinion. Let's get a tangent. What's the tangent of 60? Look at the diagram again. Right, here's a TOA, opposite over adjacent. Yes, Shay? Root 3 over 1, or just simply root 3. Put it over 1, it doesn't change anything. Why is he saying that? Because it's opposite over adjacent, which is root 3 over 1. It's just root 3. It's just root 3. Will the calculator agree with that? Of course it will. The tangent of 60 degrees is root 3. Exactly what it says. Okay, now let's go to 30 degrees. So change your orientation and start looking at this angle up here and asking the very same question. So we're not looking at 60 degrees anymore, which is down here. We're looking at it from the point of view of the 30 degree and asking all the same questions again. So who can tell me what they think the sine of 30 degrees is, looking at the same triangle, but from the 30-degree perspective? Yes, Wanya. Thank you very much, Wanya. It is, in fact, 1 over 2. Is there anybody who isn't sure about why that is? Here's my 30 degree up here. Okay, that's okay, AJ. Here's my 30 degree up here, right? And what we're saying is sine is opposite of hypotenuse, right? Right there. Opposite to 30 is the 1. The hypotenuse is 2, so it's 1 over 2. All right, let's keep going. How about the cosine of the same 30-degree angle? All right, what's the cosine? Sarah? Root 3 over 2 is absolutely correct. When you're doing this online, it's going to look exactly like that. It's not going to be some strange looking decimal. It's going to look like that. These are exact values. Okay. How about the tangent? Yes. Everybody got 1 over root 3? Good. The calculator is going to give me a little different answer, and I'll explain why in a second, but it is 1 over root 3. If I ask the calculator for the tangent of 30 degrees, let me see if anybody can tell me why it's giving me this strange number. The tangent of 30 degrees is that. What? Where did that come from? That's not, is that 1 over root 3? Doesn't look like 1 over root 3. It looks like root 3 over 3. Is the calculator broken? Did I just mess up? Did I enter the, is it in the wrong mode? What just happened? Yes. It's the rationalized form of 1 over root 3. So let's just do a quick thing here. I go to a brand new page. If I have 1 over root 3 and I rationalize it, multiply by the root 3 over root 3, then the root 3 times the root 3 gives me what again? Root 3 times root 3 is 3. The top is just simply root 3. So root 3 over 3 is the same thing as 1 over root 3 in rationalized form. The calculator is going to give you the rationalized form. On the online test you're about to do, you're going to see 1 over root 3. It's not going to be rationalized. So you won't have to be worried about what the calculator is saying, because I would prefer that you leave it as 1 over root 3. Here's the answer that I'm going to be looking for from you. That's what I'm looking for. And that's what's going to be on the quiz when you get to the quiz shortly. Okay? Let's keep this little show going here. So now we've filled out for 0, for 30, for 60, for 90, for 180. But there's some other angles that we haven't touched yet. And for that, we're going to go to triangle number 2. So triangle number 1 was this, as we heard earlier from Sarah, is what we call an equilateral triangle. What kind of triangle is that one? The second one. It's not equilateral. What do we call that one? It is a right angle, but there's more to it than that. There's something else that I'm looking for. Yes. It's an isosceles triangle. You have 2 equal sides. These 2 sides are 1 each. Yes, so it is a right triangle, but it's a right isosceles triangle. So this is 1, that's 1. That's the root of 2, using Pythagoras again, but you can confirm that for yourself. 1 squared plus 1 squared is equal to x squared. Well, 1 squared plus 1 squared is 2. X squared equals 2, so x is equal to the square root of 2. I don't need to write that down. Just accept that that is the square root of 2. If these 2 sides are 1 and 1 each, that's going to be the square root of 2. Can we accept that, first of all, before I go any further? Is that good? What do you say to that, Ashton? Does the square root of 2 make sense to you? Okay, good. Now, if it's an isosceles triangle, and it's a right triangle as well, it means that these 2 angles are both equal. They have to be. Because it's a right triangle, half of the degrees in a triangle, which is 180, is in the right angle. So that leaves you to split up the rest between those 2 angles. So if that is the case, what would those two angles be? Yes, 45 degrees. Thank you very much. Let's put that in. And they're both 45 degrees, by the way. Now, just before the break, which will come up in about 4 minutes, we're going to fill in that 45-degree column row right now. Start thinking about what the sine of 45 is, using SOHCAHTOA, the cosine of 45, and the tangent of 45, based on this triangle that we just drew, and the sides that are labeled, it's 1, 1, and root 2. See if you can figure out, write it in for yourself, and we'll get to you in a minute. Write in what you think the sine of 45 is. Write in what you think the cosine of 45 is. I'm not going to put on the calculator yet. And put in what you think the tangent of 45 degrees is. For yourself. You would put it in pencil, just in case it's wrong. I'm seeing some pretty good answers here. Well, I'll take a volunteer. What's the sine of 45 degrees? Go ahead.
I got it 1/2.
You got that because that's correct. 1/√2. I'll get to the calculator in a second. How about the cosine of 45 degrees? Yes, Shaheen. That's the answer I just got from Naomi for sine. You're saying it's the same thing for cosine? Oh, look at you. Okay, 1/√2. He's not changing his mind. And the tangent, yes, Jay, is in fact 1. Okay, let's ask the calculator for the tangent of 45 degrees. Can you predict what the calculator is going to say? Can anybody predict what the calculator is going to say? Is it going to say 1/√2? What do you think? Yes. Is it? It's going to say 1 for the tangent of 45. What did I say? Oh, not tangent. Not tangent. Sorry, I didn't mean okay, tangent of 45 is 1. Let me just say, yeah, that is 1. I meant to say sine of 45. Okay, now who is brave enough to tell me what you think the calculator is going to say? Okay, let me hear what Suchi thinks is going to say. Yes. Oh, so not 1/√2 then, because it's going to rationalize it. Oh, okay, I got you. I got you. So Suchira is suggesting that the calculator is going to agree with the 1/√2, but not present it as 1/√2. And he's right, √2/2. Again, rationalized, right? But it is 1/√2 in disguise. Okay, kind of, right? It is 1/√2, but rationalized. All right, so fill in for sine, cosine, and tangent of everything that we've done so far. All right, we're going to talk about what happens when we move outside of that first quadrant in a minute. All right, but I'm going to put the pause button on. The quadrants that we've been talking about. And I'll remind you what we said before, that cosine, let me start with sine actually. That sine is my y, sine is my y, cosine is my x, and tangent is my y divided by my x. In fact, let me move this whole thing over a bit, give myself a little bit more room down here. Now, if that is true, my x-axis is right here, my y-axis is right there. If I'm in the first quadrant, I'll call this quadrant 1. I'll call this quadrant 2. I'll call this quadrant 3. And I'll call this quadrant 4. That's generally how they're numbered. So starting off on the positive side of the x-axis, we're going to be rotating this way, as we just did with that arrow. And in the first quadrant, I'm going to ask you to tell me which of these three things, sine, cosine, and tangent, which one of them would be positive? Well, they should all be positive. because I'm on the positive side of the x-axis and I'm on the positive side of the y-axis. So it means that sine should be positive because I'm on the positive side of the y-axis. Cosine should be positive because I'm on the positive side of the x-axis. And tangent should be positive because I'm dividing a positive by a positive. So I'm going to say that in that quadrant, they're all positive. All. A for all. Let's go to the second quadrant now. I'm going to give you a clue. Only one of them is positive in that second quadrant. Only one is positive in the second quadrant. What do you think about that, Hashim? Which one is positive? Okay, so I'm asking sine, cosine, and tangent. Which one is positive? Sine will be positive. That's exactly right. We'll put an S there for that. Let's go to the third quadrant now. I'll give you another clue. Same clue I gave for the second quadrant. Only one of them is positive in the third quadrant. Only one. The other two are negative. Can anybody tell me which one is going to be positive? Yes. Tangent. There you go. Because both x and y are both negative, and you divide a negative by a negative, get a positive. So tangent is actually positive in this quadrant. Let's go to the fourth quadrant now. What's happening in that fourth quadrant? Yes, Atifa. Cosine is positive in that quadrant. And why is that? I'm on the positive side of the x-axis. This is sometimes referred to as the cast rule. These letters spell the word cast, C-A-S-T, going in that counterclockwise direction, starting off in the fourth quadrant. That's how some people remember which quadrant is positive as you go in that circle, going counterclockwise, right? It's called the cast rule. Right? So if you draw a set of quadrants and put the CAST on there, you can immediately know which is positive, which one is negative. So I'll give you an idea. In the second quadrant, is cosine positive? No, because only sine is positive. Let's go to this quadrant. Is tangent positive? No, because only sine and tangent, sorry, only cosine is positive. The other two are negative, but they're all positive in that quadrant. We call it the cast rule. So that's a little what's called mnemonic, which helps you to remember which one is positive in that particular quadrant. All positive here, sine positive here, tan positive here, cosine positive here. Spells the word cast. All. In fact, I'll write that down. ALL, sine, tan, cosine. That looks like a 21. So all, A for all. Let's see how this helps us out now. I'm going to go back to my little circle here that I had. And I'm going to start looking up angles. Go back to the chart for down here for a second. I'm going to start looking up angles that are bigger than 90 degrees. So that's just 120. So my first question is, let me go to a brand new circle. All right, let me use black actually. Where's 120 degrees? Is it quadrant one? Let me label the quadrants again. This is quadrant 1. This is quadrant 2, 3, and 4. Where is 120? Remember now, we're starting off. I'm going to remind you where we start off. Right? The arrow starts off over here. Let me put that in a different color. Make it in red. The arrow starts off over here at 0. That's my 0 right there. So where would 120 degrees be is the question. Yes, Gary? In the second quadrant. In the second quadrant. In fact, let's put that there right now. It's going to look something like this. So the question you have to ask yourself is, now remember, I'm measuring 120 degrees starting off here. I'm always going to start off at the positive side of the x-axis, and I'm going in that direction. I'm going in a counterclockwise direction, 120 degrees. The question you always have to ask yourself is, what is what's referred to as the RAA, which stands for, I'll write that down, the RAA stands for the related acute angle. The related acute angle. Now we know this is not an acute angle. 120 degrees measured from here is not an acute angle. It's supposed to be 120. It's not exactly 120. I'm just saying, it's not, it's not drawn to scale or anything. But that's an obtuse angle. That's bigger than 90 degrees. So what is related to that? What angle can I use to represent that, which is an acute angle, is the question. Oh, you think you have an answer already? What do you think that is? Wow! That's all I'm going to say to that. She's right. Here's how we get the related acute angle. Look for your x-axis and ask yourself, how far away am I from the closest x-axis? So I'm not measuring from over here. I'm measuring to this x-axis right here. And my related acute angle is whatever this angle is, that's going to get me to my closest x-axis. So if I've gone 120 degrees, excuse me, if I've gone 120 degrees, I need another 60 degrees to get me to the x-axis. Excuse me, I just need a pause here. Try to think about whether that makes sense to you. That 6 degrees is the gap that needs to be made up to get you to the closest x-axis. That number is the number we're going to use. That related acute angle is what we're going to be using to represent the 120 degrees. But bear in mind, it's in the second quadrant. And that's going to be significant for when we try to get our answers in a few minutes. So, excuse me. Since 120 degrees is related to 60 degrees, we're going to use 60 degrees for our answers. So I'm going to start by asking for the sine of 120 degrees. And I'm going to say that that should be the same as whatever the sine of 60 degrees is. It should be the same. The other question is, should it be positive or negative though? That's the other thing we have to answer. But we need to go and look up, well, let's answer that question first. Should that be a positive for that quadrant for sine, or should it be negative? Right? We are agreed that the CAS rule should apply. So should my answer be a positive or should my answer be a negative? That's the question I'm asking. Okay, let me go in the back and ask, darn, and I thought I had it, but give me 1 second here. Charmaine, yes, Charmaine, sorry, Charmaine, go ahead. Pardon me?
Positive.
Should be positive because I'm in the second quadrant. Sine is positive in the second quadrant. So whatever the sine of 60 degrees is the same as the sine of 120 degrees. So what you need to do is go to your chart on the very first page, find the sine of 60 degrees in that chart. Looks like it's root 3 over 2. And it's going to be the same thing for 120 degrees. So write that into your chart. If you're lucky, that might come up in one of the questions, so you don't even have to think about it. Make sure you understand why, though, that the sine of 120 is root 3 over 2. How about the cosine of 120? Well, the cosine of 120 would be the same as the cosine of 60, but should I make it negative or should I make it positive? That's the question I need to ask. Should it be positive or should it be negative? Okay, let me go in the back and ask Hashim that. It should be negative. So whatever we had for the cosine of 60 before is going to be the same answer for this, but just negative. Let's go back to the chart. Look for the cosine of 60. Cosine of 60 was a half. This answer should be negative a half. How about the tangent of 120 degrees? Well, the tangent of 120 degrees should be the same as the tangent of 60 degrees. But should I make it positive or should I make it negative? That's the question. Yes, Gary, what do you think? Should be negative. So go ahead and look for the tangent of 60 degrees in the chart. And whatever the answer is, I'm going to make that answer negative. What's the tangent of 60 again? Look it up in the chart. I don't remember it, by the way. I'm just going to be honest with you. I don't memorize these things. I go and I use my triangle and I figure it out. Yes. Negative root 3. If you stop me on the street and ask me for the tangent of 120 degrees, I wouldn't have an answer for you right away. I have to start thinking about the triangle. I don't like memorizing stuff. I like knowing how to get it by thinking it through, but I don't like memorizing things. So there's your answer. So go ahead and fill that line in for 120 degrees on your chart. Let's get to 135 now. So I'll put that in for you as well. So this was root 3 over 2. This was minus 1 over 2. And this was minus root 3. Let's go to 135 now. So 135, you get another brand new chart for that. Sorry. What quadrant am I in for 135 degrees? What quadrant am I in? Okay, Masumi. Quadrant what, sorry? Quadrant 2. I still haven't got all the way to quadrant 3 yet. I'm somewhere between 90 and 180. So I'm still in quadrant 2. I put that arrow in like I did the last time. Oh, that's not what I meant to do, but anyway. From here to here is 135 degrees. But I need my RAA now. And my RAA is how far am I from the closest x-axis. Go ahead, Abel. 45 degrees. So my RAA is 45 degrees. So it means that anything I want to find out for 135 degrees, I'm going to use my related acute angle. So let's get to the sine of 135 degrees, the cosine of 135 degrees, and the tangent of 135 degrees. I don't know why I wrote the whole thing out. Give me a second to correct that. They're all going to be equivalent to something to do with the sine of 45, the cosine of 45, and the tangent of 45. Okay, some of these are going to be positive and some of these are going to be negative. How about the sine? Should that be positive or that should be negative? What do you think? Positive or negative? Positive or negative? Yes. Should be positive. And what was the sine of 45 again, by the way? What's the sine of 45? Let me go to some people who haven't been putting their hands up. Thank you very much to all the people who have been so diligent and conscientious in volunteering. We're going to talk to people like Athusa now. So it's 1 over root 2. And it's still positive. How about we said this was going to be negative. Actually, I don't think I asked the question yet, but it is going to be negative. Why is it negative? Because I'm in the second quadrant. The only thing positive in the second quadrant is sine. So look up the cosine of 45 now. We're going to make that, whatever that thing is, negative. Sahil. Good. Tangent of 135, should that be positive or should that be negative? Abdullah, what do you say? It should be negative. And it's negative what, sorry? Negative 1. Fill in all that information on your chart right now. So for 135, I can put in 1 over root 2, negative 1 over root 2, and minus 1. Let's get to 150 now. 150. I see the hands. Thank you very much. Emily, I need some help. I'm going to put 150 on the board and ask you to tell me what quadrant you think we're going to be in, and also how far are we from the closest x-axis. Okay? So, first of all, here's my x and y axis. Where do I put my 150 degrees? First, second, third, or fourth quadrant? What's that? Second. You said second? Okay, good. Somewhere between 90 and 180 is where 150 is. So let me put that arrow in. Somewhere about here. So that means that from here to here is my 150. But the other question I have for you, Emily, is, thanks, what's my related acute angle? In other words, how far am I from the closest x-axis when I'm at 150? I'll put that 150 in. When I'm at 150 degrees, I'll be 30 degrees away. So my RAA is 30 degrees. So any question I'm going to ask about 150 can be answered by looking at 30 degrees. So here are the questions. What is my sine of 150 equal to? What is my cosine of 150? What is my tangent of 150? We said that in each case, the RAA was 30. So it's a sine of 30, it's a cosine of 30, it's a tan of 30. But some of these are going to be positive, some are going to be negative. Which ones are positive and which ones are negative? Rosie, your time. Which one should be positive, which one should be negative? Sine is positive, cosine is negative, and tangent is negative. Just like the ones before. So let's answer the question now. What's the sine of 30? Well, it's in the charts. Look up the sine of 30. What is it equal to? Okay, yes. 1 over 2. Still positive. What about the cosine of 30? Look up this. It's in the charts, right? There are the charts. All right? Go ahead, please, Wanya. Would it be negative root 3 over 2, as you said? And finally, what about the minus the tan of 30? Yes. Negative 1 over root 3. Put those numbers into your chart as well. Now, we're going to have angles that are going to be thrown at you in a minute. That are going to be some of those numbers that you have in front of you, but some of them you're going to figure out for yourself. Let's go to 210. Next one from the chart. I'm not filling in that line. I'm going to go to 210. Come on, where am I? Here we go. We'll do 210 and we'll do 300 and I'm going to stop from the positive side. Then we're going to go negative after that. Let's go to 210 now. So I'll do 210 and I'll do 300 and I'm going to stop. All right. I need your help, Jaheen. Where do you think 210 is in the scheme of things? Is it quadrant 1, 2, 3, or 4? 210. That's my question for you, Jaheen. Quadrant 3, good call. Somewhere between 180 and 270. That's where 210 is. So here comes my quadrants, and here comes my arrow. Oh, sorry. Here comes my arrow. Somewhere down here. And measured from here, that's 210. But I'm going to stick with you, Jaheim, because I need the RAA now, the related acute angle. What do you say that is? What's my RAA? Pardon me? 360, you said? 60 degrees? I'm actually going to disagree with you. Sorry. I'm actually going to disagree with you. It is not 60 degrees. And let me tell you again, look for how far you are from the closest x-axis, not the closest y-axis. It's never the closest y-axis. How far am I? How far is 210 degrees from the closest x-axis? What do you say to that? How far away is that?
Would it be the one? Would you go backwards or would you go forward?
What do you think?
I don't know. That's what I'm asking.
Okay, well, let me answer it this way. If I needed to get to the closest x-axis, should I be going forward or back? Okay, good. Now answer the question. How far am I from that closest x-axis? An acute angle. Somewhere between 0 and 90. I'm looking for a related acute angle. Thanks for offering. We're going to work this through with Aria right now. You're right. You said go back. I agree. How far back? Because that's going to answer the question. How far back do I need to go to get to that closest x-axis is the answer for my RAA. Let me hear your answer for that. Think it through. Okay, let's think it through then. Tell me the position of the closest x-axis. What angle is that? X-axis. To get to the x-axis from the start, what angle is that? 90 degrees is the y-axis. 0 is all the way over there. This is 0, right?
Yeah.
I'm not concerned about the y-axis. Isn't that the closest x-axis? What angle is that? Thank you. How far am I from that? If I'm at 210, Hashimi, listening to us? All right, that's what I need you to do. Thank you. Thank you very much. 30 degrees. So my RAA is 30 degrees. That's my closest angle to get to my x-axis. X-axis is home. I want to go home. Yeah, some of you are probably thinking that right now. Right? I need to get home. So how far do I need to go to get home? Home is on the x-axis. If I'm at 210, I just need 30 degrees to get there. So my related acute angle. So when I ask for sine, cosine, and tangent of 210, I'm going to use 30 degrees. So my sine of 210 is the same thing as the sine of 30 degrees. Same. Now we're going to talk about this positive or negative in a minute, but it's going to be whatever 30 degrees is. Well, we may have to change the sign. We'll see in a minute. The cosine of 210 is going to be the same. I see your hands. Just give me a minute, please. It's going to be the same as the cosine of 30 degrees. And the tangent of 210 is going to be the same as the tangent of 30 degrees. Okay, your questions. Yes. Mm-hmm. No, no, we'll talk about negative angles in a minute. That's important because we need to get to that. But right now, we're only going to talk about going in a positive direction. And okay, all you're asking is this. I'm starting off here, and I want to go all the way here. How far away am I from X? That's it. 30 degrees is the correct answer, as we just heard from Aria. Now, some of these are positive, and some of these are negative. And that's where Jasmitha comes in. Jasmitha, which one or ones are positive, which one or ones are negative? When I asked the question earlier on, Jaheim told me that I'm in the third quadrant. So that's significant. Go back to the CAST rule and answer my question now. Which one is positive, which one is negative? Go. Is it sine that's positive, or is it cosine, or is it tangent? Or which ones are negative? You can answer the question either way. Okay? Keep going. I don't know if I agree with you, but I'm just going to ask you to keep going. Remember the cast rule, right? Remember what Jahim said. Jahim said we're in the third quadrant. The third quadrant. We're going to give her a chance. Thank you for offering, everybody. You just did that. That was like 2 minutes ago. Well, I give you 2 minutes now because you already had 5. Go. All right. Put the time down and we'll come back in 2 minutes. I'll give you 3. One more. One extra minute. Back to you, Jasmita. So what? Sorry? Aha. And what about tan? Tan is also, they're all 3 negative? Don't agree with that. Sorry. Correct it. Look at what cast says. Cast is telling, put the phone down. You're not ready for the phone now. You're not ready. Just leave the phone. All right? Jasmita, back to you. Tell me which one. I'll give you a clue. Only one of them is positive, the other 2 are negative. And the cast rule is what's telling you what's going on. So help me out here, please. Why don't we turn this upside down? So you don't even think about it. All right? Why don't we just turn the screen down there? Why don't we just turn the thing upside down? All right, there you go. Perfect. All right, back to you now, Jasmita. Look at the cast rule and tell me which one is positive, which one is negative. What the cast rule is telling us. Cast is the key to this. Okay? Let me go back to cast again. And also bear in mind what Jahim told us that we're in the third quadrant. Yes, question? For which one? For 135, yeah. How far are you from the x-axis? X-axis is 180, isn't it? From 180 to 130 to 135 is how far? Subtract 135 from 180. What do you get? Thank you. Okay. Back to you. Let's go back to the cast rule. Here's my cast rule. C-A-S-T. Cosine, all, sine, tan. Jahim said we're in the third quadrant. Make sense? Is it making sense? No? Okay. I'll go over the cast rule again then. And that's okay for it to not make sense, but I really need it to stop me when it doesn't, okay? All right. What we said is, and there's a reason for this. They're all positive in the first quadrant. Sine, cosine, and tangent. The reason is, I'm on the positive side of the x-axis. That's why cosine is positive. I'm on the positive side of the y-axis. That's why sine is positive. When you divide your y's by your x's, since they're both positive, you're going to get a positive result. So all 3 of them are positive here. First quadrant. Okay? Over here, I'm on the positive side of the y, but I'm on the negative side of the x. So my sine is going to be positive, because I'm on the positive side of y. My cosine is going to be negative. I'm on the negative side of the x. And my tan is also going to be negative because I'm dividing a negative by a positive. Okay? So far, so good? Down here in the third quadrant, and that's significant because that's the quadrant that Jahim told us we are in. Hopefully, Jahim is not playing with his phone either. All right? We're saying that I'm on the negative side of the x, negative side of the y. So both cosine and sine are both going to be negative, but tan is going to be positive. We heard that from Ashton earlier on because I divide a negative by a negative. Fourth quadrant. In the fourth quadrant, I'm on the positive side of the x, but the negative side of the y. So my cosine will be positive. My sine will be negative because I'm on the negative side of the y-axis. But when I divide a negative by a positive, I'm going to get a negative. So tan is going to be negative. Okay? All right. Does that help a little bit to answer the question? Okay, good. Let's rewind now and talk about what's going on in the third quadrant, because it's the third quadrant we're talking about now for 210. And I'm going to take you back to the RA that we got, which was 30 degrees. Right, 30 degrees. But we haven't decided yet which ones are positive, which ones are negative. So help me out, please. Thank you very much. Is everybody clear on that? Does that make sense? Nakib, how about you? Are you good with that? That makes sense to you? Okay. All right. Shaluja, good? Okay. All right. Let's get the cosine and sine and tangent of 30 degrees now. Masumi, look it up in the chart for me, please. What's the sine of 30? What's the cosine of 30? What's the tan of 30? Yep. So we're going to make that negative. And we heard that's going to be negative as well. And do we make this negative as well? No. Because we just heard from Jasmita that tan is going to be positive. I'm doing one more with you now. Is that a phone over there, Jahim? Jahim, you have to understand that if you want to do well in this course, you can't be focusing on your phone. It's really that simple. Not just for Jahim, but everybody else. It's really as simple as that. More time on the phone is less time understanding what we're doing. Let's get back to this. There's a time and a place for everything. One more is going to be 300 degrees. So let's draw. And by the way, that's one of those from your chart. You can fill in 210 on your own. I'm going to do 300 now. Okay? So let me draw a new axes, X and Y. And Manahil, can you tell me where that is going to be? What quadrant am I in for 300 degrees? Quadrant 4, you say. I agree. Somewhere between 270 and 360 is where 300 is. I'm going to put that line in right now. So somewhere around here. And again, if I'm measuring from the starting point, that's where my 300 is. So 300 takes me from here all the way around to here. But my question now is, what is my related acute angle? That's my question. My related acute angle. Naomi, what do you want to tell us? Except that's not acute. So that's why we can't use that angle. You had your hand up. 30? Not going with 30. Yes, Krisha. 60 degrees. Think about how far you are from the closest x-axis. X-axis. Here's my x-axis up here. What is that gap? How far do I need to go from? Remember, this is 300. Right? I'm not talking about going back to the y-axis. I don't care about the y-axis right now. I care about home. Home is the x-axis. How do I get there? That's the question I'm asking. How do I get to that point right there? How do I get back to my x-axis? I have 60 degrees to make up to get to my x-axis. And that is why that is my RAA. So my RAA, in this case, is 60 degrees. So we're going to answer all those questions about sine, cosine, and tangent for 60 degrees. Okay? Here we go. The sine of 300 degrees is the same as the sine of 60. We'll talk about negative and positive in a minute. The cosine of 300 degrees is the same as the cosine of 60 degrees. The tangent of 300 degrees is the same as the tangent of 60 degrees. The question now, though, is which ones are we going to make positive and which ones are we going to make negative? Okay? Go for it.
Sine is negative and tangent's negative.
How about cosine?
Cosine's positive.
Good. In the fourth quadrant. Negative, negative, positive. Yes. Okay, go for it. Sine of 60. Sorry. Yeah, what's the sine of 60? Correct. Somebody else give me the one for 60 degrees now, please. Go ahead, Naomi. 1 over what? 1 over 2. We're going to keep that positive or make it negative? What's that? Good. Keep it positive, folks. That's what we need to do. Keep it positive. Masumi. So making negative, you're saying. Good. All right. So I still have to do one more thing with you before I let you loose onto your homework slash classwork assignment. And that is, if you turn the page over, you'll notice that there are some negative angles over there. Whoa. What are we going to do with that? What does that do to our search for these different angles? I see a hand up already. Some people think they might know what that means. What do you think?
Is it obtuse angle?
I was thinking of something else. Yes. How do I get to those negative angles? Yes. You're going clockwise instead of counterclockwise. That's correct. Let's do a few of those. We'll do a few of those. So I'm not putting any of these in. You can put them in for yourself. All right. I've given you the answers here. But let's go to that. Let me see if I can find that page now. Here we go. 0, I'm not going to do anything. Yes, Jahim. It's still the x-axis. Home is still the x-axis. That's where everybody wants to live on the x-axis. Nobody wants to live on the y-axis. Actually, when you get to advanced functions next year, I hope a lot of you will get there, you'll find out that we have something called co-function identities where you have to talk about the y-axis, but we're not there yet. So we're just going to focus on home is now the x-axis still. The 0 line is still the same 0 line as before. So you can put in the same 0 that you got from the first page. No different. Does anybody think they know what quadrant, before I go to writing, doing a quadrant, does anybody think they know where minus 30 degrees is? Yes. Absolutely. Absolutely. To get to minus 30, I'm going to be starting off here, but instead of going in a counterclockwise direction, I'm now going in a clockwise direction. So here is my position that I'm going to be ending up at. Here. But how far am I from the closest x-axis? Remember now, I've just gone 30 degrees in this direction. That's what negative 30 means. It means going in a counterclockwise direction. So if I'm going in a counterclockwise direction, 30 degrees away, going this way, what's my RAA? Yes, 30 degrees. Okay? I'm 30 degrees from the x-axis. I'm 30 degrees from home. So my RAA for negative 30 is 30 degrees. But it's 30 degrees in the, as somebody said earlier on, in the fourth quadrant. I'm in the fourth quadrant. So let's answer some questions now. What is the sine of minus 30? What is the cosine of minus 30? And what is the tangent of minus 30? So in every case, it's going to be the same as the sine of 30, the cosine of 30, and the tangent of 30, but we may have to change some signs based on the quadrant that we're in. Which of these will be negative? Which of these will be positive? We go to Che. Excellent. So this is negative. This is positive. This is negative. Why? I'm in the fourth quadrant. In the fourth quadrant, my sine is negative. That's the cast rule. Look at the cast rule, right? So I can now put in for sine. Yes. No. It's still where you end up. Where am I? Which quadrant am I in? Cast rule is still going to also dictate which one is positive, which one is negative. So find the sine of 30. Tell me what that is. I'm going to put a negative sign on it. What's the sine of 30? Yes. Negative a half. How about the cosine of 30? Yes. Am I changing the sign on that? No. How about the tan of 30? Yes. Negative 1 over root 3. I'm going to squeeze one more in. Then you're on your own. Let me go back to my chart for that and see. Let's see now. So I can put all of, so let's put in minus 30 right now. So minus 30 we said was, here are my answers here, was minus 1 over a 2. Oh crap, going the wrong way. Minus 1 over 2, root 3 over 2, and minus 1 over root 3. I'm going to go minus 210 on you. Let me see how you guys are going to handle minus 210. I'm going to go here. No, I'm going to go, yeah, I'll go minus 210 on you. That's my last one. It'd be interesting to hear if you can figure out what quadrant I'm in, if I'm going in a negative direction. So I'm starting at 0, and instead of going counterclockwise, I'm going clockwise. So think about that. Okay, AJ, where am I in the scheme of things? Quadrant 1, 2, 3, or 4 for minus 210? Quadrant 2? Quadrant 2. You think quadrant 2 as well? You think quadrant 2 as well? This isn't working. I used to be able to do this so well. You know, shake students away from their answers, even if they're right. Losing my touch. All right, good. It is quadrant 2. We'll show you why it's quadrant 2. I'm starting at 0. This is minus 90 to come here. That's minus 180. I'm not going to get to minus 270. Right? I'm somewhere between minus 180 and minus 270. So I'm right here. Right? So this angle going from here to here is what minus 210 is. That's in quadrant 2. As you just heard AJ say, that's quadrant 2. All right. Okay. Okay. That's good to know. So my RAA is the next question. What is my RAA? What is my RAA? Yes. It's 30 degrees. That's how far I need to get back to my x-axis on the negative side. It is 30 degrees. That's the gap that takes me from here up to here. That's 30 degrees right inside there. So my RAA is 30 degrees. All right. So my final thing I'm going to do now is, what is the sine of minus 210? What is the cosine of minus 210? And what is the tangent of minus 210? Well, we just said that the RAA is 30, so it's going to be the sine of 30. We'll figure out what is positive or negative in a second. It's going to be the cosine of 30, and it's going to be the tangent of 30, because that's my RAA. All right, question 1. Should sine be positive or negative? What say you? Yes, Atifa. Should be what? Absolutely should be positive. Cosine, should that be positive or negative? Yes, Naomi. Should be negative. And tangent, should that be positive or negative? Yes, Masumi. Should be negative. I'm just going to put the numbers in. And we had these numbers before from the previous question. We know that 30 was 1 over 2. I think you can double check that for me. We knew that cosine for 30 was root 3 over 2. But it's going to be negative. And the tangent was, I believe, 1 over root 3, which is also negative, according to what we just told you.